historically memory has been, based on standards for obvious reasons, for scale, supply chain and cost and that sort of thing. But I'm beginning to see the rise of custom memory, like custom, high bandwidth memory and that sort of thing. And so, Mark, from your perspective, why are we seeing this? Is the answer AI again, or is there more to it than that?
Well, AI is certainly the major driver to this. But again, it kind of goes to play with the incredible need to get more and more performance. What happens with customizing HBM, especially with Marvell's custom HBM solutions, is that we can pull a lot of the content that was just interfacing to those memories off of the main die for an accelerator. And that opens up a lot more area for our customers to really get the performance, the number of teraflops that they need in the design. So that makes a big difference. Like, for example, we can clear up like 25% of the die space that would have otherwise been dedicated to talking just to HBM memories themselves, and we still get even better performance of the custom HBM with about 70% less power spent on the interface to those memories themselves. And I'm sure, as you're aware, right, power has become really, really critical for a lot of these applications.
And Mark, you sort of touched on this when you were talking about Moore's Law and, hitting the wall there. I mean, custom's been long associated with XPUs and CPUs, right? And I mean, you look what, others are doing with, GPU technology, AMDs and the NVIDIAs of the world, and adjacent technologies like, and packages like memory. But is it expanding even beyond that base as well?
So we spoke about how customizing HBM is really, really important when we're integrating high capacity memory on the package. One thing that's equally important is actually the SRAM, the embedded SRAM that's actually built within the accelerator or switch or whatever kind of customized data center device you're building. We actually are building very specific, highly customized memory solutions for our customers that are really cranking out as much bandwidth as we can per square millimeter of space. And in fact, our memory solutions are providing about 17 times the bandwidth that you can get from an off-the-shelf memory today. So it's a really big deal for us. It's a really big deal for our customers, and it's kind of existential to continuing to grow performance in AI. Beyond that, not only is that high bandwidth memory, the embedded SRAM memory, incredibly important for these devices, but also high capacity memory is a huge need in the data center as well. And we address that actually with a set of product families that are optimized to allow CXL connectivity for memory acceleration and for memory pooling or capacity, enabling like 12 terabytes of memory accessible through this one highly size optimized chip. So it's a pretty special offering, kind of stacking all the different types of memory that are needed for the data center. So not only do we customize accelerators, NICs, components like that, but we're even seeing customization moving into the switch arena. And that's actually what Rishi is an expert on. So I'd really like to get his perspective on that.
Yeah, Rishi, would love to hear that.
Yeah, so on the switching side, right, it's basically what is switching all about. It's basically routing large number of packets into different segments. So there is a lookup table associated with the switch, and there is also a huge centralized buffer scheme inside the switching. And as we increase the radix of the switch, that means more fan outs of the switch. That means indirectly we are telling that there are more individual ports which are talking to the switch, more unique MAC addresses. And plus, there is also a cocktail of things going on between the layer 2 and layer 3 in terms of routing interfaces. And this all has to be all encapsulated into a large buffer size and managed accurately to do the right pipelining for the switching to happen with a very low latency. So memory inside the device, or SRAM in the device, and the overall, I would say, the management of those memory modules become very important for us in terms of fan out, in terms of also data manipulation, which is happening inside, and also at what rate, the bandwidth rate are we operating at. So overall, this whole infrastructure and the SRAM implementation on the switching side and custom switch side becomes very, very critical. In fact, I'm going to speak more about it when we talk about the different criteria of switching. Within the switch and this memory, you have different bifurcations happening because of AI, which is scale up and scale out. And
Mhm.
also with this bifurcation of, especially on scale up, there is much more requirement for memory, because scale up is something where yearly you want to utilize all of your GPU optimization. The highest OPEX what you're spending is on the GPUs. And the last thing you want is to be underutilized. And the underutilization of these GPUs are coming because of the memory. So some GPUs will be starving for memory, some GPUs will be kind of underutilized for their memory usage what they have. And the switch fabric is the one which kind of capsulates all of them, gets it into a unified structure in scale up, and provides a unique value proposition in terms of custom, where you can make sure that your investments on your infrastructure, especially on the GPU side, is kind of amortized across all the nodes.